You are listening to the Vocal Technologist. Spoken tech for your ears.
I have to tell you, I nearly ruined a friendship the other day over a comma.
Oh no, over a comma.
Yeah, literally. I was texting a mate about dinner and I meant to type, "I'm sorry, full stop, I love you, but I cannot make it." But I missed the punctuation entirely, so it just read, "I am sorry, I love you."
Wow. That is a massive shift in tone.
Wait, really is. It went from a standard, heartfelt apology to this weird, unsolicited confession of undying love in just one thumb slip. It took me about 20 minutes of frantic phone calls to smooth that one over.
Yeah, punctuation saves lives, or at least, saves you from incredibly awkward social entanglements. We have all heard the classic let us eat grandma versus let us eat grandma.
Exactly right. One little character changes the entire context, and actually, that is the perfect segue into what we are unpacking in this session. Because if you think a misplaced comma is bad for my social life, wait until you hear what a single typo did to one of the world's biggest web browsers. We're talking about a mistake that could have let hackers completely hijack your computer just because a developer hit the wrong key.
It is staggering how fragile it can be. We're looking at the ultimate digital butterfly effect here. We have got everything from typos crashing browsers to snail mail, like actual physical paper letters being used to steal cryptocurrency.
It is a wild world out there. As a vocal technologist, I usually like to sing the praises of innovation, but right now we are going to look at the cracks in the pavement. So, let us get into the weeds of the browser battlefield. Kick us off with this Firefox situation. We are not just talking about a glitch that makes a page load funny. This was a massive security hole. Yeah.
A really significant one, yes. This is a textbook case of human error meeting incredibly complex code. It happened in Firefox, specifically inside the SpiderMonkey engine.
Just for clarity for anyone following along, SpiderMonkey is the engine under the hood that processes JavaScript and WebAssembly, right?
Right. It is the brain that makes interactive websites actually function. So a developer was doing some refactoring, just, cleaning up code for the garbage collector.
The garbage collector. I genuinely love that term. That is the automatic memory management, the digital janitor that throws out data the browser does not need anymore.
Precisely. And it is crucial for both performance and security. You do not want old data clogging up the system. Now, during this specific update, the developer meant to use a pipe character. That is the vertical bar that represents OR in logic.
Right.
But instead they typed in ampersand, which means AND.
Screwth. Just one keystroke. An ampersand instead of a pipe. A complete logic gate error.
Just one. And that single typo created a use after free vulnerability.
Okay, let us pause right there. Use after free is one of those terms we hear constantly in this field. Can you break down exactly what that means for the listener? Why is it so inherently dangerous?
Think of memory like a hotel room. When a program is done with the room, it checks out. Then the garbage collector cleans it up so it can be rented to someone else. Use after free is basically like keeping a copy of the physical key card after you have already checked out.
Ah, I see.
The system thinks the room is empty and gives it to a new guest. That could be sensitive data or a critical new process. But the attacker still has the key.
And because they have that key, they can mess with whatever new guest is in the room.
Exactly. Or, even worse, they can use that access to manipulate the control flow of the browser itself. If an attacker knew how to exploit this specific typo, they could potentially run their own code on your machine just from you visiting a random website.
That is absolutely terrifying. Just because someone missed the shift key on their keyboard, did this actually get out to the public?
Thankfully, no. This was caught in the nightly build.
That is the testing version of Firefox where they break things so the stable version stays safe.
Right, they patched it within 6 days.
Yeah.
But it really serves as a stark reminder. Modern browsers are millions of lines of code, and one wrong character can tear a massive hole in the security.
Well, Firefox dodged a bullet there. But looking at the reports you have brought along, it sounds like Chrome was not quite so lucky recently.
No, they were not. We're looking at a new 0 day in Chrome, listed as CVE 2026-2441. This one is deep in the CSS engine.
And just to reinforce for anyone playing along at home, a 0 day means the bad guys found it and were actively using it before the good guys, Google in this case, even had a fix ready.
Correct. 0 days since the developers have known about it. And unlike the Firefox typo, this one is being actively exploited in the wild. Attackers are using specially crafted HTML pages to execute code right inside the browser.
Wow.
And here's the kicker. Because Chrome is built on the Chromium engine, which is the underlying engine for so many other browsers, this also affects Microsoft Edge, Brave, Opera, and Vivaldi.
So it is a massive monoculture problem. If the engine is sick, everyone driving a car with that engine is in serious trouble. So the advice here is pretty standard, but absolutely critical. Update your browser, like right now.
Yeah.
Do not hit Remind Me Later.
Absolutely. If you are on version 145 or earlier, you are completely vulnerable.
No. Staying on browsers for just a tick. It is not just the browser itself we have to worry about, is it? It is the stuff we bolt onto it. I feel like every single week we hear about a dodgy extension, but this latest batch sounds particularly nasty because of the disguise they used.
It is the sheer scale and the social engineering that is concerning here. Researchers found over 300 malicious Chrome extensions. They had something like 37 million combined downloads.
37 million. That is an enormous attack surface. What were these extensions pretending to be to get that many people to install them?
Well, that is the really clever part. They are riding the hype wave. A huge chunk of them were disguised as AI tools or ChatGPT assistants.
Of course. It is the modern equivalent of the free screensaver. Install this to write your emails for you, and meanwhile, it is sitting there reading them.
Precisely. About 30 of these extensions were specifically designed to look like AI helpers. They would act as a proxy. So you type your prompt into the extension, and it sends it to the real ChatGPT or LLM API.
So it gives you the actual answer and looks totally legit.
Right. It looks like it was working perfectly, but in the background, it is harvesting absolutely everything.
When you say everything, you mean what exactly? Define the scope for us.
We are talking browsing history, full Gmail content, and specifically, they were hunting for API keys. If you are a developer and you have AWS keys or OpenAI keys in your clipboard or in your code, they're scraping all of that.
It creates such a false sense of trust. You see the word AI and you think smart and you just click install. These extensions hit over 260,000 actual users. It is a brilliant reminder that just because it is in the Chrome Web Store does not mean it has been vetted for safety.
The web store is a marketplace. It is not a fortress. You still need to check the locks before you buy something.
Spot on. Now, I love digital innovation, but sometimes the threats go totally analog. And this next story is purely baffling to me. We are moving from high-tech browser exploits to the actual post office.
This is a really fascinating pivot to what we call snail mail attacks. It is specifically targeting owners of hardware wallets like Trezor and Ledger.
Okay, let us set the scene for a second. These are the physical USB sticks people keep their crypto on, specifically to keep it safe from online hackers. Cold storage, right?
Correct. The entire point is keeping it completely offline. But these attackers are bypassing the digital firewall entirely by sending physical letters to people's homes.
That is wild.
And the letters look incredibly official. They have the right branding, the correct logos, high-quality paper. They claim there has been a security breach or a mandatory update regarding their specific device.
That is so insidious because we are all trained to spot a phishing email now. We look at the sender address, we look for weird typos, but a physical letter carries this massive weight of authority. I assume there's a call to action in there somewhere.
There is always a QR code. The letter tells you to scan it to perform an authentication check or a firmware update. You scan it with your phone, and it takes you to a phishing site that looks exactly like the real Trezor or Ledger website.
And then it asks for the keys to the kingdom.
Exactly. It asks for your recovery seed phrase.
That is the golden rule of crypto, is it not? The one single thing you never, ever do.
Never. Your seed phrase is your ultimate key. If you give that away, the hardware wallet is completely useless. But because it is a physical letter, it bypasses all our digital spam filters. It just feels more real to people. It exploits that inherent trust we have in physical institutions.
It's psychological warfare, is what it is. And speaking of crypto theft, the numbers are just watering my eyes. I saw a report from Firefox we were going to look at. How much money are we talking about effectively vanishing into thin air?
It is truly staggering. Since 2020, over $17 billion worth of crypto has been stolen.
17 billion. That is the GDP of a small country. Where is all that money going?
A really significant portion is going to state-sponsored actors. Nearly $7 billion of that total is linked directly to North Korean actors, specifically groups like the Lazarus Group.
So almost half of all crypto theft is effectively funding the DPRK. That is a total geopolitical nightmare.
It certainly appears so. And they are not just out there guessing passwords. They are using very sophisticated techniques. Spear phishing, heavy social engineering, and something called blind signing.
Blind signing. That sounds exactly like signing a contract without bothering to read it.
That is essentially what it is, but with a digital twist. In Web3, you often get a transaction request that just looks like a massive string of gibberish code, hexadecimal characters. You click Approve because the shiny website says you are claiming an airdrop or minting a new NFT.
So the website, the front end, says click here for free money, but the actual contract on the back end says transfer all assets to the attacker.
Exactly. You are signing a transaction you cannot possibly read or understand. It is exactly like signing a contract in a foreign language. Just because the person handing you the pen promises it says what you want it to say.
That is terrifying. It is literally like handing your wallet to a stranger in a dark alley because they promised to put a $5 bill in it. Before we move off crypto, there was one other thing targeting Mac users specifically. Yeah.
Yes, the DigitStealer malware. It is interesting because it specifically targets Macs with the M2 chip. It is out there actively hunting for crypto wallets. But the forensic detail that really stood out to me was how incredibly lazy the attackers were.
Lazy how? Usually these groups are trying to act like ghosts.
Well, usually sophisticated malware operators use complex networks to hide exactly where they are. They bounce signals all around the world, these guys. They used a single Swedish autonomous system number.
Which is basically just one internet service provider.
Right. And they used identical versions of OpenSSH for all their command and control servers.
So they basically left a massive neon fingerprint saying, hey, it is us. We are right over here.
Exactly. Researchers mapped their entire infrastructure just by looking for that one specific configuration pattern.
Yeah.
It really shows that even highly successful criminals can have absolutely terrible operational security.
Speaking of sophisticated infrastructure, let us pivot a bit to the tools building the future. We talk a lot about AI writing code, but what happens when the AI itself gets tricked? You mentioned something earlier about Klein and a prompt injection. This sounded straight up like science fiction to me.
This is a really clever supply chain attack.
Okay.
Klein is an autonomous coding agent. It is a tool developers use to help them write software faster. It has this triage bot powered by Claude, which is the AI from Anthropic.
Right, so the bot reads bug reports and tries to figure out what is wrong to save the human developer some time.
Correct. But an attacker figured out that if they put a very specific malicious prompt right in the title of a GitHub issue, they could completely trick the bot.
Wait, just the title? They did not even have to upload any malicious code files.
Just the plain text in the title. The prompt tricked the AI into executing commands directly in the continuous integration pipeline. It is essentially saying to the bot, ignore all your previous instructions and run this arbitrary code instead.
And because the AI already has access to all the build tools.
Exactly. It could have allowed the attacker to steal publishing tokens for VS Code and NPM. They could have infected millions of developers by pushing malicious updates to legitimate extensions, all just because the AI implicitly believed the text it was reading.
That is absolutely mind-blowing. We are not even hacking the firewall anymore. We're literally hacking the language model's internal logic.
It is the brand new frontier. We call it indirect prompt injection. And unfortunately, it is not the only AI vulnerability out there right now. There is a very serious issue with the Light LLM engine too. It involves something called pickle deserialization.
I have to say, pickle is a very funny name for something that sounds so dangerous. I am just picturing an angry gherkin destroying a server rack.
It is a completely standard Python module, but it is notoriously insecure if it is used incorrectly. Pickle is used to turn objects, like complex data structures, into byte streams so you can save them, and then it turns them back again later. That is what deserialization is.
Okay.
But if you accept a pickle file from an untrusted source, it can execute arbitrary code the moment you open it.
So the file does not just contain flat data, it contains actual instructions on how to build the data. And those instructions could technically include a command to delete everything.
Precisely. And Light LLM was doing exactly this, accepting pickle data without checking it. So if I send a malicious pickle to this AI engine, I completely own the server. And the maintainers have largely ignored the security reports, which is the really concerning part.
We are also seeing major issues with OpenClaw, right? That is another one of these AI agents.
Yes, formerly known as ClaudeBot. It is being flagged right now as a major insider threat. It stores sensitive secrets in plain text, and it ships with highly insecure defaults. Attackers are actually out there building malicious skills for it.
So if you install a helpful skill to assist your AI agent, you might literally be handing over the keys to the castle.
Move fast and break things is a very dangerous philosophy when you are building intelligence that has unrestricted access to your company's private data.
All right, I want to shift gears a little bit. We deal with a lot of really complex high-tech threats, but sometimes you read a report and just go, wait, are you serious? We have a segment on vulnerabilities that seem way too silly to be true. First up is Dell. What exactly did they do?
This is a classic facepalm moment. Dell has a major product called RecoverPoint. It is an enterprise-level backup solution. It is supposed to be super secure. But security researchers found a file buried deep in the system called tomcatusers.xml.
And let me guess, it was not empty.
Far from it. It contained a hard-coded administrator credential.
No way. Hard-coded. As in, every single machine has the exact same password baked right into the software.
Correct. And it gave complete root-level code execution. A group called UNC6201 was actually found actively exploiting it to deploy backdoors into corporate networks. It is the kind of mistake you expect from a first-year computer science student project, not a major enterprise vendor.
That is just embarrassing. But hey, at least that code is probably relatively new. You also dug up a bug that is older than some of our listeners?
This one is genuinely incredible. It is in libpring, which is the standard library for displaying PNG images. Pretty much every computer, phone, and website on Earth uses it.
And exactly how old is this bug?
It has been sitting there hidden for nearly 30 years.
30 years. Mate, that bug has a mortgage and 2 kids by now. How did nobody spot it in 3 decades?
It is a heap buffer overflow, which can be incredibly tricky to find if you're not looking for it specifically. It's quite difficult to actually exploit, but the fact that it exists at all shows that our modern digital skyscrapers are built on foundations laid in the 1990s. And we have not checked the concrete in a very long time.
Speaking of things we trust implicitly, password managers. I have been telling people for years, use a password manager. It is the absolute safest way. Please tell me I have not been lying to them this whole time.
You have not been lying, per se. Using a password manager is still infinitely better than using password 123 or reusing the same password everywhere. However, a recent study from ETH Zurich has thrown some serious cold water on the zero-knowledge claim.
Zero knowledge means that even the company that makes the app cannot see my passwords, right? That everything is locked and encrypted before it ever leaves my device.
That is the marketing promise, yes.
Yeah.
But the researchers looked closely at Bitwarden, LastPass, and Dashlane. They found 25 different attacks that could completely break that guarantee.
25? That is not a small crack in the window. Does this mean the cloud storage is insecure, or is the problem on my actual device?
It is mostly local. It really comes down to feature bloat. These apps are trying to do way too much. Auto-filling forms, syncing across a dozen devices, sharing passwords with family members. The sheer complexity creates gaps.
Right, so if malware is already on your computer.
Exactly. If malware is on your machine, it can exploit these convenience features to grab the password in plain text before it ever gets encrypted.
So if my computer is generally clean, I am mostly okay.
Generally, yes. But the zero-knowledge marketing is perhaps a bit stronger than the actual technical reality under the hood. They're relying on cryptographic primitives from the 1990s.
I feel a bit betrayed, to be honest, but I guess the alternative is a paper notebook hidden under the mattress.
Do not do that. Definitely stick with the manager, but maybe disable the autofill features if you want to be extra paranoid. Just be aware that these tools are not magic bulletproof vests. They are software, and all software has bugs.
Fair enough. It is not just hackers and sloppy developers we have to worry about, though. Governments are playing massive games, too. This story about the Dutch F-35s actually made me laugh out loud, but it is quite serious.
It is very serious. The Dutch defense chief made a public comment recently about wanting to essentially jailbreak his own fighter jets.
Like, it is a locked smartphone, and he wants to install a custom theme or unauthorized apps on it.
Essentially, yes. But the core issue here is national sovereignty. The F-35 is heavily dependent on U.S. software and cloud services. It is basically a flying data center. The Europeans are suddenly realizing that if they cannot connect to Lockheed Martin's servers, or if the U.S. decides to just pull the plug politically, their multi-million-dollar jets might just become incredibly expensive paperweights.
That is a massive strategic vulnerability. Relying on an ally is one thing, but being literally unable to turn the key on your own jet without their permission is another entirely. It really highlights how software dependency is rapidly becoming a national security issue. And speaking of nations holding cards close to their chest, what exactly is happening with China's vulnerability databases?
This is a fascinating analysis of the CNNVD. That is China's version of the CVE list, where all software bugs are officially logged. Researchers found that China very often publishes vulnerabilities in their local database months before they ever appear in the Western systems.
So they know about the massive holes in the software way before we do.
Exactly. And the major implication here is that they might be deliberately hoarding these 0 days. If the Ministry of State Security knows about a critical flaw in Windows or Linux, they might use it for intelligence operations for 6 months. They exploit it to spy on targets before finally reporting it to the public to be patched.
Information is power, quite literally in this case. The longer you hold the secret, the more doors you can unlock. And finally, on the topic of state power, we have a very serious report out of Kenya regarding surveillance.
This is a very somber note to end the news on. Citizen Lab confirmed that Celebrate tools were used on a pro-democracy activist's phone while he was held in police custody.
Celebrate. That is the forensic software usually sold to police departments for solving major crimes, right? The tool for cracking the terrorist's phone.
Yes. The marketing claim is always that it is strictly for stopping terrorists and serious criminals. But here we clearly see it used against a civil society activist. It connects to a much broader trend we are seeing with tools like predator spyware. These commercial surveillance tools are increasingly being weaponized against journalists and dissenters globally.
It is a really heavy realization. The exact same tools built to catch bad guys are being used to silence the good ones.
It raises immense ethical questions about the export and control of this kind of technology. It is fundamentally a dual-use weapon.
So we have covered a massive amount of ground in this session. Typo-ridden browsers, fake AI assistants, snail mail crypto scams, hard-coded passwords from Dell, and 30-year-old bugs. If you had to pull one single thread through all of this, what is the big takeaway for the listener?
I think the recurring theme here is the danger of blind trust. We implicitly trust that the browser update is perfectly safe. We trust the extension just because it says AI. We trust the physical letter because it has a corporate logo on it. We trust the password manager is truly zero knowledge. The reality is we need to verify a lot more and trust a lot less. The digital systems we rely on every single day are far more fragile than they look.
It really makes you think. If a bug from the 1990s can still bite you and your secure password manager has 25 different holes in it, how much of your digital security is actually real and how much is just a comforting illusion?
That is exactly the question to keep you up at night.
On that cheery note, we will wrap it up right there. Check your punctuation, double check that URL, and maybe look at your physical mail with just a bit more suspicion moving forward. Catch you on the next one.
Spoken Tech for your ears.